Welcome back to my channel. I'm so excited to have you here. If you have more questions for me to solve on this problem, on this particular topic we're going to be handling today, kindly drop them in the comment section. Please like the video, comment, share, and start. Our topic is extended and compact form of a matrix. In our last video, I showed you that a matrix A can be represented as what? Aij m by n. So this part of the matrix equation is called the extended form, where you have the whole big part of the matrix having rows and columns. Okay, now but this part is just the compact form, where you have entries, okay, represented entries, say one entry Aij represented, and then this is just the dimension of the matrix. Okay, note, a matrix in extended form can be represented by more than one compact form. Alright, this will help us when we are tackling problems of converting from extended form to compact form, which we are going to do now. So let's do that. Write in compact form. B is equal to let's take something different from what we usually do. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what do we have? We have Bij is what? How many rows? 1, 2, 3. 3 by how many columns? 1, 2, 3, 4 by 4. Very important. Now let's write in compact form. So Bij is equal to what? This is the time to see. Open your eyes. Okay, so what I like to do is actually compare this. Okay, so the same thing we did with compact form to extended form, we're going to do it now with extended form to compact form. So what do we have? We have this is equal to A11, A12, A13, A14, A21, A22, A23, A24. Let me write this one. Then we have A31, A32, A33, A34. So look, when we have this, what happens? Looking at this row, is there anything common happening? What can I see? I can see that when I have A11, I have 1. When I have A12, I have 2. When I have A13, I have 3. When I have A14, I have 4. So what are you saying? That the column part is exactly what is produced. Column is called what? J. Okay, so this happens when J is equal to, when this gives me J when I is equal to 1. Okay, what do I mean? When I have 1, 1, I have 1. So when I have 1, 2, I have 2. So it's giving me j, the column part, when my I, that's my row, I'm on the first row. Okay, so keep that. So analyzing the second row now, we have A21 will give me 5, 6. Okay, alright, we're on that row. A22 will give me 6, A23 will give me 7, A24 will give me 8. Okay, A31 will give me 9, A32 will give me 10, A33 will give me 11, and A34 will give me 12. Okay, my board is quite small. So let's see. This time this will give me what? 2. Okay. This time this will give me 4. This time this will give me 6. This time this will give me 8. Okay. Well, if I add 3, that's going to give me 5. If I add 2, if I add 1, if I add 0. Okay, I can see a pattern anyway. I can see that if I multiply I and j, right, and then add, what will I add now? I'm adding from 3 to 1. Is there anything I can do? I'm finding it difficult to work with this. Okay, I would have said I minus j, or but it won't work. Okay, let's try something else. So now that I've tried times, we can try, if I try minus, I'll just be killing everything because my numbers are increasing towards the side. Okay, so let's just try plus. So if I add, I have 3, if I add, I have 4, if I add, I have 5, if I add, I have 6. Cool. If I add 2 to each of them, I'm good to go, right? If I add 2 to each of them, I'm good to go. So what does that mean? It simply means what? It means I plus j plus 2. So let's try analyzing this. What do we have? Using the same thing we did, we're adding. So we have 4, 5, 6, 7. So, but if I add something, it cannot work. So what do? I know that if I add 5 everywhere, it will work, right? Cool. If I do that, then my compact form will be something like this: Bij 3, 4 will give me what? I plus j plus 2 if I, this is equal to, sorry, is equal to 2, and then I plus j plus 5 if I is equal to 3. We can't really work with this. Okay, let me tell you why. This is not a compact form. This is more or less like describing the matrix. So compact form usually have 2 sides or 1 side. Okay, that's shrinking it up. Okay, so but here we have 3 sides. So all we need to do is try to join one or more. Okay, so let's see if that can happen. This plus this is 8, right? Right? And I is 3. So that's actually 2 raised to the power 3, right? This plus this is, I is 2 here, okay? Plus 2 is 4. Okay, 4 is 2 raised to the power 2. So you can see that actually this is I here, this is I here. Okay, so it's just like j plus 2 raised to the power I. So see what I did again. I have I here. My I here is 2 because this is the second row. Okay, 2 plus this 2 is 4, And 4 is the same thing as what? 2 raised to power 2. This is 2 raised to power I in this position. Okay, now I said I here is 3 plus 5 is 8, right? That's 2 raised to power 3, and I is 3 is the same as 2 raised to power I. So what we have here is what? J plus 2 raised to power I, j plus 2 raised to power I. So we can shrink it. Okay, I couldn't do that here because if I say 2 raised to power 1, I is 1. If I say 2 raised to power 1, then we are totally wrong. You get 2 raised to power 1 is 2. J plus 2 gives 1's of course is not equal to j. So let's just join these two rules. If you're learning anything, you're gaining from sight or anything whatsoever, please give this video a thumbs up, like, share, and comment. So this was j plus 2 raised to power I if I is not equal to 1. So we're going to be using this now to get back our b. Let's see. That's just checking back. I love checking back because it makes me see whether what I've done is right or wrong. So checking, we have b is equal to, we say it's a 3 by 4 matrix, so keep that in mind. When I is 1, I have j. My j is what? Let's just write out like we said, b1 1, b1 2, b1 3, b 3 4. Alright, so now that we know that b is what? When I is 1 and we're on this row, so I is 1 means what? J. So the other side, the column side is what? 1 2 3 4. I think that's what we're given, so we've gotten that part. So the next thing is to check j plus 2i if I is not equal to 1. So where is I not equal to 1? Here and here. Okay, so let's take the first one, when I is not equal to 1. When I is not equal to 1, we have j. J is what? 1 plus 2 raised to power I. 2 raised to power I is what? 2. 2 raised to power 2, because I is now 2 here. So this is the second rule where I is not equal to j. And in this second rule where I is not equal to j, you have 2 raised to power I is what? 2 raised to power 2, because our I is 2. 2 raised to power 2 is 4 plus j, whatever your j is, these are your j's. Okay, so you keep adding 4 to your j's. So 1 plus 4 is what? 5. Good. 2 plus 4 is what? 6. 3 plus 4 is 7. 4 plus 4 is 8. So we've gotten the first rule and the second rule. So good. We are moving forward. Now we are in the third row. In this third row, we have what? What do we have? We have that I is 3. So 2 raised to power 3 is what? 2 raised to power 3 is 2 times 2 times 2. That is what? 8. So we're going to be adding 8 to the j's. Okay, these are your j's. Okay, 4. Yeah, okay, good. So we have what? 8 plus that. So 8 plus 1 will give me 9. 8 plus 2 will give me 10. 8 plus 3 will give me 11. 8 plus 4 will give me 12. And this was exactly our third column. So that means this is indeed our compact form. Okay, and remember to put your right hand side as this part of it. Okay, bij 3 by 4 is equal to what? J if I is equal to 1, and then j plus 2 raised to power I if I is bigger than 1. Bonus, I'm going to give you something. I want you to know that this b can be represented in many forms. Another form it can be represented with is j plus I squared minus 1 if I is odd. So what did we do here? We actually just combined the first rule and the third rule. I is odd means first rule and the third rule. So previously we said that is equals to j if I is equal to 1, is equal to this if I is equal to 2, and is equal to this if I is equal to 3. So what do we have here in common with the odd coordinate is what? The odd component is what? I is equal to 1 and what? I is equal to 3. So this one. Okay, so looking at those two now, what is common is j, so keep it aside. So the first one has what? J plus 0, while the other one is what? J plus, our I is what? 3, 8. Okay, j plus 8, right? But I squared here, I squared here is what? 3 squared. 3 squared is 9. So 9 minus 1 gave me 8. But here, 1 squared is 1. 1 minus 1 will give me 0. So if I have odd components, it's the same thing as writing j plus I squared. When I is 1, I squared is 1 minus 1. When I is 2, when I is 3, I squared is what? 9 minus 1 will give me this. So we get them back. So that's the second one. And then for here we have what? This is 2, I is 2 here for the second rule. Okay, so 2 plus 2 is 4, and same thing as 2 raised to power I, because I is 2. 4 is 2 raised to power 2. J plus I squared if I is even, or where I is even. Anyone, you can put it as anyone. So you have two formats I'm giving you. You can challenge yourself to get more formats, okay, of compact form. And for today, we're going to be stopping here. I will leave an exercise for you. My exercise is write in extended form, okay? Write in extended form A I J. This is a 3 by 2 matrix, okay? So 3 rows, 2 columns. 3 by 2, where we have minus 1 raised to power I times j. So this j is down, it's sitting down, it's not raised to the power, okay? Plus I, okay? Okay, this is a 3 by 2 matrix, okay? So try to get the answer. Alright, you can leave your answer in the comment section. Thank you for watching. Please like my videos, subscribe, share, and I really appreciate your view. Thank you.